Hello everybody. Now we'll see about clocked SR flip-flop. Before watching this video, kindly check my previous video SR latch using NAND. Now we'll see clocked SR flip-flop. So how the previous SR latch we know how it will be. There will be two NAND gates and cross coupled. One of the input will be given with another output. This is Q and this is Q dash. Okay, so in this clocked SR, what happens means we are now applying clock. One of the input we are giving it as clock, and this is S and this is R. Okay, so it is constructed adding two NAND gates to the basic SR latch. This is the basic SR latch. We are adding clock signal to it. When clock signal is high, the circuit acts as low input SR latch. That is, it inverts. Instead of giving a S dash or R dash, this clock determines this SR. If it is a high means S equal to 1 or equal to 0 means it's in set state. 0 and S equal to 0 or equal to 1 means it resets it. When clock is low, when clock is 0 and this is 0 means it it holds the previous state. Okay, no changes will be there. Only if clock is equal to 1, there will be change. Okay, this you have to keep it in mind. Clock is equal to 1 only, the output will change. Otherwise, if clock is 0 means no change. Okay, so now we'll see one by one the case. So now here the SR clock is 1. Okay, so this is 1. Always this input is 1 and S equal to 0 or equal to 0. So this is 0 and this is 0. What happens? 0, 1 means it will be 1. Here also 0, 1 means it will be 1. So this is the NAND logic. If NAND logic, what happens? XY output. If one of the input is 0, it will be 1. This you have to keep it in mind. Okay. Now, let the case be now Q equal to 0 and Q dash is equal to 1. What happens? This becomes 0. Is one of the input is 0 means this will be 1. So, this is 1 means this will be 0. And even though if it is the case, okay. Now if Q is equal to 0 and this is 1 means what happens? This is 0 and this will be 1. This is 1, this will be 0. So whatever the Q value, if it is 0, 0 means it remains the previous state. Okay. Now next, clock. If now always clock will be 1, otherwise no change will be there. Now S is equal to 0 or is equal to 1 is the case. So this is 0 and this is 1 and clock is 1. What happens here? So 0, 1, one of the input is 0 and this must be 1. For 1, 1 it is a 0. So if here if it is the case means this input is always 0 and this must be 1. Okay, and if it is here 1 means this is 0. So whatever the value of Q and Q dash, it will be, if it is S is 0 and R is 1 means this input will be always 1. So this output will be 1 and so here the output changes to 0. So if it is 0 and 1 means qn plus 1 will be 0. And what is the next case? Clock is 1 and S is 1, or is 0. Okay. So 1 1 means 0, 1 0 means 1. So here what happens? Here one of the input is 0. So always this must be 0 whatever the value of q, and this is 1 means this will be 0. So whatever the value of q is 0 or 1, this input will always be 0. So this must be changed to 1, and this output will be 0. So for this case, s equal to 1 or equal to 0, qn plus 1 will be 1. And what is the next case? Last case is clock is 1, s is 1, or is 1. What happens? 1 1 means 0, 1 1 means 0. So here if it is 1 means this must be 1. So here one of the input is 0 means this must be 1. So this complement and the uncomplemented one cannot be 1 at the same time. So this is invalid. Okay. Now what is the truth table of SR flip-flop? Now this latch becomes flip-flop because we are adding clock to it. If we are adding a clock, it becomes flip-flop. So if it is clock is 0 means whatever the value of SR, this next state will not change. It remains in the previous state only. And if it is 0 0 0 1 1 0 1 1 combination, and if a clock is 1, 0 0 means it previous state it holds. 0 1 means it is the reset state. 1 0 means it is the set state. 1 1 means it is the invalid. It is not allowed. This is the truth table. So this holds the previous memory. This is the reset state, and this is the set state, and this is 1 1 combination not allowed. So that's all about SR clocked flip-flop. Thanks for watching.